Around the time ChatGPT was first released, we saw this initial wave or first wave of these new kind of AI agents called LLM agents, or large language model agents. And over the years, the next few years, the number of research papers on these AI agents or LLM agents doubled roughly every year. And so today, AI agents, they're finally leaving the research lab and entering the world of business. And interest in AI agents obviously has exploded here over the past year. And so now everyone, all of my clients and everyone I talk to are interested in building these AI agents. So this has led to numerous conversations with my clients and with others about what AI agents are. So the three things that everyone seems to want to know right now: what are AI agents, what they can do for me, and what comes next, what's after once we get these AI agents up and running. So the purpose of this presentation is to essentially answer all three of these questions. As an overview of our presentation, first we'll learn about AI agents in general, like intelligent software systems that can be used to automate work. Then we'll look into interface agents, agents that provide a natural language interface to some kind of computer subsystem. Then we'll look into workflow agents, which are agents that execute a predefined sequence of steps to complete a task. Then we'll learn about semi-autonomous agents, which are agents that complete tasks using an iterative feedback loop. Then we'll look into self-improving agents, which are agents that can improve their own performance and by modifying themselves. And finally, we'll learn about autonomous agencies, which are multi-agent systems that are all working together to complete a common goal. All right, so let's start from the beginning. What are AI agents? Well, an AI agent is a machine that perceives its environment and chooses actions that maximize the expected likelihood of achieving a goal of some kind. Essentially, it's just a machine that observes, reasons, and then acts, and then uses feedback from its actions, the changes in the state of the environment, in order to make the next decision. But it can also include other enhancements like adding memory to it, so it can remember information, giving it tool use capabilities, self-reflection, chain of thought reasoning, a bunch of different augmentations. And now the current wave of these AI agents are all built on large language models. So what are large language models? Well, a large language model, or LLM, is an AI system that, when given a sequence of words, is trained to predict the next most likely word. And this is the technology that powers everything from ChatGPT to Copilot to Gemini. So LLMs, they use a series of impressive AI technologies and techniques to predict the next most likely word. And then we feed that we feed the previously generated words back into the model, including the new generated words, and then it's going to predict the next word, and so on, so on. We call this autoregressive prediction. And then we keep going until we reach some kind of stop token, like the period at the end of the sentence. And this allows us to communicate with large language models in natural language. We provide a request in plain English, and then the LLM is going to provide a response. For example, if we ask the LLM, what is the capital of France? It's going to respond with the word Paris. And then if we ask a follow-up question like, well, what is the population? Now, the LLM knows from the prior context, the prior text that we typed to it, that we're now talking about Paris. So it's going to respond with the population of Paris based on this context. And because we can continuously feed our previous chat history into the LLM, this allows us to have an interactive dialogue or conversation with the large language model. And this ability has led to the amazing success we've seen in these modern chatbots like ChatGPT, Gemini, Copilot, Claude, all of them that you see right now. They're all pretty much working roughly the same way. And this leads to an interesting question. So what if the LLM was having a conversation with a computer rather than a person? So rather than us having a conversation with it and getting answers back from it, what if we instructed it to talk to a computer on our behalf? And that leads us to the concept of an LLM agent. So an LLM agent is an AI agent that uses a large language model as its core engine of computation. It's a software system that interacts with the world around it, but solely through text. And there are a lot of different types of these LLM agents all kind of emerging right now, which is causing quite a bit of confusion in the industry, and especially with my conversations with clients. We're talking about agents, but they're talking about this kind, I'm talking about this kind. We are not on the same page. So to help me and my clients have more productive conversations, I attempted to group all of the different types of agents that I was seeing both in the industry and coming out in AI research, and then give them a name so we could at least talk about this kind of agent versus that kind. And so we're going to walk through each of these in order from the simplest to the most complex type of agent. Okay, first, what are interface agents? Well, an interface agent is an LLM agent that provides a natural language interface to a computer subsystem of some kind. Now, a subsystem can be a tool, an application, a database, or some other repository of information. The interface agent allows us to have a conversation in plain English with that tool or subsystem. And this can include tools like a calculator, a web browser, a search engine, code interpreter, or data analytics, data visualization tools. So instead of having to learn how to use each of these tools individually, we just have a natural conversation with the tool, and it does all the hard work for us in the background. And this can also include applications like word processors, spreadsheets, video editors, email clients, or developer IDEs. No more having to remember how to create a pivot table in Excel. You essentially just ask for the data to be transformed, and Excel does it for you. That and lookups, God, nobody can remember how to do those. This also includes other computer subsystems like databases, the file system, the operating system, a website, an API, or even the entire internet can be a repository that you speak to. We don't need to understand how to write a SQL query anymore to ask the database a question. We simply just say, give me the top sales by region in the past quarter, and it's going to construct that SQL query, execute it, and return the results back to us. And this also includes other repositories of information like FAQs, tech support systems, and CRMs. We just ask a question or assign it a task in plain English, and the agent does all the hard work and gives us the answer. Now, these interface agents are typically subdivided into one of two kinds. We have query agents, which answer questions for a user using the subsystem as the repository of information. For example, asking a tech support system to diagnose an issue with a new product based on the existing tech support logs that are out there. And action agents, these execute commands against the subsystem that change the state of the subsystem in some way. For example, creating an appointment on your calendar for a meeting with a new client. And you can see that there's two different kind of risk levels with these. Like the query only is a different kind of risk versus being able to modify the state of the system. And now for the developers in the room, there's kind of a natural parallel here between what we call application programming interfaces or APIs and natural language interfaces or NLIs. So the APIs, they allow us developers to communicate with the subsystem using structured data and function or method calls. However, these systems, they're brittle, they're fragile. As a human, you don't want to be typing this stuff by hand in order to, you have to get it right every time. And otherwise the call is going to fail. But computers, software is really good if it's been programmed to do exactly that every time. Now, these natural language interfaces, or NLIs, they allow end users to communicate with these same kind of subsystems, but with natural language instead of structured data and method calls. They're much more flexible and robust. They can handle deviations from the expected output, handle those kind of edge cases and anomalies. They're very flexible. But NLIs, they're not just good for humans to interact with these subsystems through natural language. Other LLMs can also talk to them through these natural language interfaces in natural language. So we end up with agents talking to other agents, which is an interesting concept we're going to discuss here in a bit. So let's see just a couple quick demos of these interface agents just to give you an idea of what they look like. First, let's take an interface agent that I created for my website. This agent is an interface to all of the knowledge contained in my website. For anyone interested, I take all of the pages, I convert them into Markdown, I load them into a retrieval augmented generation vector store, and I can retrieve paragraphs of the information based on what the user is searching for. And then I just provide a user interface to it. And I instruct the agent to always provide sources, and if it doesn't know the answer, say, I don't know. All right, so we'll ask it a quick question like, where does Matthew work? Now, the agent is going to go off and look for all of the potential things that involve the word work or things like work, and it's going to come back with Matthew Renze is the founder of Renze Consulting, an AI consulting company. Ask it another question like, what is Renze Consulting? It's going to look for things like the words Renze Consulting or consulting agency, things that are like consulting, and we can see it knows that it's an AI consulting company that I founded. We can ask more general questions like, how do I get started with AI? And I've written tons of articles on this topic, so it's going to pull back, like 5 different articles, snippets from it, and try to synthesize what the best practices are. I'm going to put it in debug mode here real quick and ask it, where's the best sushi in Las Vegas, which I've written about in my FAQ. So You'll see here in yellow the keywords that it's using to search, which are semantic searches, not exact keyword searches, and the list of articles, the sources of information it's determining its answer from. And we can also ask it a question that it shouldn't know the answer to, like what is the price, how much do eggs cost today? And it will just flat out say, I don't know the answer, but if you have any other questions, feel free to ask. And so just by giving this agent this retrieval augmented generation capabilities, it significantly reduces hallucinations. It doesn't just make up information. With just always provide a source to your information, and if you don't know the answer, just say I don't know. All right, and now here's a demo of a much more complex and powerful interface agent. This is Microsoft's Power BI Copilot. We'll just kind of walk through a couple of tasks that are being performed with it. So you can start by giving it tasks like build me a sales report summarizing our key metrics and trends. And you get this nice data visualization with all of the information coming from its data repository. You can ask it a question like, what are the biggest drivers for closing a sale? And you can see it comes back with the answer. Giving a call back within 3 hours is the highest predictor, which you can see in plain text. It responds in that little sidebar. You can ask it to do things like summarize the data, and it gives you a narrative summary here. And we can also do other things like ask it for a table of the top 50 customers by sales. And when you do this, in this specific case, it's going to show you the query, the SQL query that's going to be executed against the database. So you could modify that query if you needed to, if you know SQL, and you're going to get back those top 50 results. So you can see it's literally just doing all of the work of the data scientist, the data engineer, like all of the low-level stuff that most of us don't enjoy doing. We like getting the answers rather than doing all the work to get the answers. So the key takeaway here is that these interface agents provide a natural language interface for our tools, applications, data repositories, and other subsystems. They act as a wrapper for one or more computer subsystems so that a human or another LLM can communicate to it in plain English. Okay, next up, we're going to talk about workflow agents, and this is the one that I think is the most confusing to a lot of people right now. So a workflow agent, which should more appropriately be called an agentic workflow, is a sequence of predefined steps that combines traditional programming logic with LLMs. Some of the steps involve LLMs. It allows us to create automated workflows that are more powerful and more flexible because they incorporate LLMs in some of the steps where it makes more sense than traditional, like explicit programming. Now, think of a traditional automated software workflow. We've got this sequence of predefined steps. Some of the steps might access subsystems like a database, and others might branch out into multiple steps or loop back to a prior step if need be. For example, we could imagine an automated tech support workflow where a user submits a tech support form, which is going to consist of a bunch of highly constrained fields, drop-down boxes, check boxes, things we have to do to get the information into a form that the machine can work with. Next, the workflow agent then validates all of the data in the form for the things that the user might have added that it shouldn't have or in the wrong format. Then it queries the database for a user ID to get the user's profile, adds that user's profile to the tech support request, and then finally decides which department to send or what urgency to send it as high priority or low priority based upon who the user was, because our CEOs want their stuff fixed right away, and how high priority the user claimed that the problem was. Now, on the other hand, we can have an agentic workflow. And with an agentic workflow, we use an LLM to handle some of the steps that aren't easy to complete or aren't possible to complete with traditional programming logic. So for example, imagine an automated workflow for booking the best hotel room based on a user's preferences, but all in plain English, where the user's just saying, hey, I need a hotel room, I like the room on the top floor next to the elevator, like all of this different stuff, but without having to fill out a bunch of check boxes and drop down forms. So the user requests the hotel room with their preferences in plain English. Next, the LLM searches for the rooms based on those preferences. Then a workflow calculates the rates for the various room options, another step that's better done with traditional programming, like doing the math. And then a second LLM re-ranks the top rooms based on all available information. And this doesn't have to be structured table data. This could be pulling snippets of data from different websites, completely different formats, merging it together and making sense of it. And then if the top room is available, the workflow books it. Otherwise, it would ask the user, which of these top 5 rooms would you prefer? And now let's take a look at quick examples of agentic workflows, like real world ones. So here's one using a tool called N8N. With N8N, we can build visual workflows using a drag and drop user interface. And in this example, this workflow essentially scrapes the latest 3 articles from my website and then just gives a summary of those articles. So during the first half of this workflow, we're just dealing with traditional programming logic. The workflow is triggered manually. I click a button which starts it. It gets a list of websites, articles from my website. Then it extracts the names of the articles straight from the HTML. It splits the articles into multiple items so they can be processed in sequence. It keeps only the top 3 most recent articles, and then it gets the text from the body of the article. And then we move over to the LLM part of the workflow. The LLM summarizes each of the 3 articles. It uses OpenAI's chat model to do the summarizations, and it loads the article text into the large language model using a data loader called the recursive character text splitter. And then at the end, we go back into traditional programming logic. The workflow merges the article's titles, which were extracted from the raw HTML, with the summary of the article generated by the LLM. We have some post-processing just to clean up using traditional programming logic as well. And then finally, we output this summary of the last 3 articles from my website. So now let's take a look at a more complex agentic workflow, one that generates WordPress articles from a few SEO keywords. And no, I do not use this myself. Like, I write all of my articles by hand. But a lot of people are using this stuff. And this right here, this is why, if you've ever heard of the dead internet theory, why it is either likely already true or will be true before long. Okay, so this one involves multiple LLMs in the steps and multiple generative AI. So first, the user enters a list of keywords to construct the article, so all the tech buzzwords that they're looking at that week. Next, it retrieves settings for the WordPress website. Then the LLM creates the article's title and outline based on those keywords, and it's using Wikipedia as its source of information. So if it needs to talk about Teslas, it will look at the Tesla webpage in order to get information to write, I guess, factually accurate or hopefully factually accurate information. And then it checks if the data created by the LLM is formatted correctly, which is another non-LLM step. Then it splits the outline into a list of sections, and then another LLM for each section is going to write that section, and then the title, the outline, and the text are going to be merged into one article, and the final article text is then prepared in that next step. Then the article is posted as a draft on the WordPress website so that we can generate a new image using DALL-E 3 to upload that image to the WordPress website and set it as the featured image for the article. And finally, the workflow prompts the user to verify that the article is correct or make any corrections or switch out the image or whatever needs to be done. But you can see, I mean, this is, I hate to say it, this is like somebody's full job, like a whole day's worth of work that can be automated in a couple of seconds or minutes. So the key takeaway here is that agentic workflows allow us to automate more tasks more flexibly than traditional workflows and more cost effectively. They handle edge cases and anomalies better, and they allow us to automate tasks that simply could not be automated using traditional programming logic. All right, so what are semi-autonomous agents? Semi-autonomous agents are LLM agents that complete tasks using an iterative feedback loop of observation, reasoning, and action. Some of you have heard of React agents. That's essentially what these are. The agent observes the state of the environment, reasons how to complete the next step in the task, and then performs an action that gets it closer to its goal. All semi-autonomous LLM agents right now are all using roughly the same 3-step process or something similar. Sometimes they add self-reflection or some other things into it. First, the user specifies the task to be completed. The agent will sometimes have make a plan first. Then the agent reasons about how to complete the first step in the task. Then the agent performs an action. And finally, the agent observes how the action changed the state of the environment. And based on this feedback, the agent then decides what the next step should be and repeats this 3-step loop over and over until either the task is complete, it runs into a problem it can't solve, or quite often, they get caught in an infinite loop they just cannot get themselves out of. So let's take a quick look at an example of a semi-autonomous agent in action. We'll start with a simple example of making coffee in a basic virtual world. Kind of a toy example. So the user specifies, make me a cup of coffee. The agent, first thing it does is observes, I'm in a room with a coffee maker, 2 cabinets, and some other kitchen appliances. It thinks to itself, well, I should open cabinet 1 to get the coffee. It executes the action, open cabinet 1, which then it observes that cabinet 1 contains the coffee can. I should grab the coffee can. So it now tries to grab coffee. However, it reports an error saying that the action failed. And so it reflects on what it did wrong and realizes, oh, I should have grabbed the coffee can instead of trying to grab coffee. So now it grabs coffee can, and it observes that the coffee can is in my right hand. A trivial example, but kind of gives you a sense of how this iterative loop and feedback loop works. Now, to make these agents more powerful, we can also provide them with various cognitive enhancements, things like memory so that they can remember across one task to the next, tool use like search engines, web browsers, and code interpreters to be able to write and execute code to solve more complicated problems, and self-reflection so that they can learn from their previous mistakes. So there's numerous cognitive enhancements for these AI agents. There's literally thousands of tools, APIs, plugins, integrations, etc. for these agents to use. And adding more of these capabilities makes the agents more powerful, but it comes at the expense of potentially overloading them with too much information, and the cost goes up pretty heavily as well too, the more tools you try getting them to use at the same time. Ultimately, it hurts their performance and increases their cost. So there's ways that we can minimize some of these problems. We often will break up the agents into a bunch of smaller sub-agents, one for each tool, API, plugin, or integration, or subsystem, and then we have a single manager agent that delegates the work to each of the sub-agents. And this allows the sub-agents to specialize in their specific tool or plugin or API or subsystem, and prevents the manager from getting overloaded with too many low-level responsibilities. So now let's take a look at a more kind of real-world example of a semi-autonomous agent in action. This is an example of trying to get the combined revenue from the top 3 tech companies. So the agent first thinks to itself, I should search for the top 3 tech companies. It performs the action using its search engine, top 3 tech companies by revenue. And it's going to get the results, Amazon, Apple, and Google. So then it's going to go through its next step. I need to get the revenue for Amazon in 2024. It might have to do a search first before this, but then it will browse to the quarterly or the annual report for Amazon in 2024. It sees that the result is the $604 billion, and it repeats this for Apple and for Google to get that information. Then it's going to calculate the total revenue. It uses its built-in calculator tool to add those 3 numbers together. The result, 1317, it interprets that as the answer is $1.3 trillion, and it responds with 1,317 billion to the end user, completing the task for that user. And now I should point out that these agents are not fully autonomous. They're intentionally semi-autonomous. We don't want them to be fully autonomous. Rather, they're instructed to ask the user for help if they get stuck, get permission before performing any tasks that are deemed high risk, and request additional information if something is unclear with the steps. Okay, so now we're going to take a look at real-world examples of semi-autonomous AI agents. We're going to start with Manus, a state-of-the-art semi-autonomous agent that was just released, I think it was last week, or maybe this week. I mean, everything's such a blur right now. It's hard to remember. Okay, I'm going to let him do the talking.
Let's start with an easy one. In this example, we'll ask Manus to help screen resumes. I've just sent Manus a zip file containing 10 resume documents. Since each Manus agent has its own computer, it worked like a human, first unzipping the file, then browsing through each resume page by page, and recording important information to documents. Manus works asynchronously in the cloud, which means you can close your laptop anytime, and Manus will notify you when everything is complete. Of course, you can also give Manus new instructions at any time. Here I've sent Manus 5 more resumes. After carefully reading all 15 resumes, Manus provides the ranking suggestions along with candidate profiles and evaluation criteria as supporting materials. This is pretty good, but I prefer a spreadsheet. Let's have Manus create one. Manus has its own knowledge and memory, so it can teach Manus that the next time it handles a similar task, it will deliver a spreadsheet right away.
And if you guys want to see more of those demos, I can show them at the end. It's just really impressive to see how far these semi-autonomous agents have come recently. In fact, I had an application for a virtual assistant here a while back. I think I had something like 250 applications submitted. And having to go through 250 applications, I mean, this takes a long time. Fortunately, I have a lot of AI tools in my toolbox, so I was able to get through all of those applications relatively quick by comparison to most. But having a tool like this would have definitely saved me at least days worth of time trying to decide on a new virtual assistant. All right, and here's the second demo. This is Devin, a software developer agent that writes code, fixes bugs, designs user interfaces, and creates documentation for new software from scratch.
Devin, the first AI software engineer. Let me show you an example of Devin in action. I'm going to ask Devin to benchmark the performance of Llama on a couple of different API providers. From now on, Devin is in the driver's seat. First, Devin makes a step-by-step plan of how to tackle the problem. After that, it builds the whole project using all the same tools that a human software engineer would use. Devin has its own command line, its own code editor, and even its own browser. In this case, Devin decides to use the browser to pull up API documentation so that it can read up and learn how to plug into each of these APIs. Here, Devin runs into an unexpected error. Devin actually decides to add a debugging print statement, reruns the code with the debugging print statement, and then uses the error in the logs to figure out how to fix the bug. Finally, Devin decides to build and deploy a website with full styling as the visualization. You can see the website here.
And so now that whole thing is very impressive to me. It can't build like super complicated applications, but throwing together a prototype, getting something quick on a website, I mean, there's a lot you can do with a tool like this right now. As a developer myself with over 20 years of experience, maybe 25 now, the thing that I find most impressive is that it is smart enough to know, hey, there's a bug here. If I add some debug trace logging, I can figure out what the bug is easier. And that's, I don't know, that to me is just ridiculously impressive. And then it solves the problem that way. So if you want to build your own semi-autonomous agents right now, we've got developer frameworks right now like LangChain, Semantic Kernel, AutoGen, and OpenAI's, it was Swarm, it just got renamed Agent SDK like yesterday or the day before. You describe what each sub-agent is supposed to do, essentially in English, in code as well, and then connect the sub-agents together to complete the tasks. And then for the non-developers in the room, you can also create semi-autonomous agents using tools like N8N. You build them similar to how you build the agentic workflows, but these don't have to follow like predefined steps. You're building more of the kind of architecture for the agent, just connecting all of the plugins and stuff that it needs. And there's even more user-friendly tools coming very soon. Microsoft's got their Agent Studio, where you literally just have a conversation with an agent to build the agents. And then anytime the agent does work and gets stuck, you have a conversation with another agent that helps you figure out why that agent got stuck, and it learns how not to get stuck next time. I mean, it's just, this stuff is just crazy cool, but a lot of it's not ready for production yet. It will be this year though. Okay, so the key takeaway here is that these semi-autonomous agents, they can complete complex multi-step tasks through this feedback loop of observation, reasoning, and action. And they can perform tasks with minimal oversight. I mean, they still require human intervention, and we want them to require human intervention when they need permission to do stuff and when they're uncertain about things or something seems a bit risky. Okay, next, self-improving agents. All right, so self-improving agents are LLM agents, or I say LLM, which is large language model, but a lot of these are now large multimodal, or LMM, or MLLM, depending upon who you talk to. So they can work with both language, or they can also work with the text, image, audio, and video too. So I just need to clarify that at some point in time. So these self-improving agents are either LLMs or LMMs that can improve their performance by modifying their own code, data, or parameters. The agent learns how to solve like new, more complex problems by making itself more powerful with each iteration. So let's take a look at an example of a simple self-improving agent. In 2023, AI researchers created an autonomous Minecraft agent called Voyager. So Voyager explores the world of Minecraft to learn new skills. It uses an LLM to write code to solve problems that it encounters, and it stores problem-solving code as functions with text-based descriptions in a skill library. It works like this. So first, Voyager just starts exploring the environment to encounter new problems, to learn new skills. Every time it encounters a situation in the game, it creates a new task. Now, it searches its skill library to see if it already has a skill that knows how to complete that task. If it finds a matching skill, it retrieves the code from that skill to perform the task, and then it executes the code to complete the task. However, it also uses feedback from the environment to see if the code actually solved the problem or not. If the skill didn't solve the problem, or it can't find a matching skill, something that will actually solve the problem, then it begins writing new code to solve this new problem. It also has a second LLM that verifies the new code to ensure that the code works as expected. And if the code doesn't work correctly, it will kick it back to the code writer LLM, who will then refine the code, send it back to the tester for another test, and they keep iterating like this until they've got code that they believe will actually solve the problem. And then once the code works as expected, it gets added to the skill library. So finally, when the agent encounters a new situation that requires this new skill, it can retrieve the new code to solve that problem. And now this self-improvement strategy has led to an autonomous agent, the one in orange, that could play Minecraft better than, significantly better than any previous AI agent. It obtained 3 times more unique items, explored 2 times further distances, and unlocked key tech tree milestones 15 times faster than any prior Minecraft agent. And here's what it looks like in action. So we'll see here it's using the gather cactus skill, which is just a set of code that says this is how you gather cactus. We can see it swimming. Here's it executing its catch fish skill. Its hunting pig skill, which when you kill the pig leaves you a pork chop behind. We can see it fighting an Enderman, which my nieces tell me is one of the harder enemies to defeat, but not as difficult as the Ender Dragon. I was supposed to clarify that. Is that? I have no idea. Is it a shovel? Here we see mining gold. And now mining amethyst. I don't even know what amethyst is used for. But the last thing we'll see here is it mining diamond, which is the most difficult resource, I guess, to mine or to craft with. So that's essentially like you're at expert Minecraft player level when you're mining diamond. And there's various types of these self-improvements that agents can perform on themselves. They can modify their own system prompts through something we call prompt re-engineering or self-re-engineering. They can create skill libraries like we saw with Voyager. They can fine-tune their own models to become better at specific like subtasks. They can curate or synthetically generate new training data and then retrain their models from scratch. They can rewrite their own code. They can modify their own software architecture, spawn new specialized subagents to complete new tasks, and perform automated AI research to improve the state of the art. And that's something that a breakthrough is just kind of happening like in this last couple of months. We're seeing the first AI research papers solely authored by AI research agents. Yeah. And this is the direction of AI research is currently heading. Very soon, it is predicted that we will have literally millions of these autonomous AI research agents all reading literature, proposing hypotheses, running experiments, analyzing data, and then communicating the results to other autonomous AI agents. But in a feedback loop, much, much faster than any humans can do. Like anyone that's ever submitted an AI research paper to a conference, like this is a 6-month process just to get accepted to the conference. So from the time you start doing your research until your research is published is like a year. And so we've got a bunch of like short-circuiting mechanisms, like we pre-print the paper before we submit it to the conference or journal. And if you're submitting to a journal, good luck. Like that's a 3-year process almost. So it'll be tough to compete with that level of research. Okay. Finally, what are autonomous AI agencies? So an autonomous agency is a collection of agents or a multi-agent system where the agents are all working together on a set of tasks to complete a common goal of some kind. Think of it like a traditional organization, like a business or a nonprofit, but the majority of the work is being done by these software agents rather than people. Not all of it, but the majority. To better understand, let's return back to our single agent. So we've got the single agent that essentially interacts with a series of tools and subsystems. However, as we mentioned earlier, giving it too many tools and tasks and subsystems, that tends to overload it with too much responsibilities and increases the cost as well too. So we create a series of worker agents or sub-agents that are specifically designed or specialized for each specific tool or subsystem. And then we have the manager agent delegate tasks to each of these worker agents using natural language instructions, not in code, just, hey, I need you to build me a spreadsheet with something and send it to this agent who's then going to analyze the data. But we can also have peer-to-peer communications between these manager agents. They can flexibly coordinate to complete their respective work more efficiently via collaboration. We call them AI swarms. So our agents can work together through peer-to-peer or hierarchical communication styles, just like humans do in traditional organizations. So today, we have traditional IT organizations composed of these IT subsystems at the bottom with software applications running above them, humans, users that use them to complete their workflows, who are managed by human managers, who are then guided by executive leadership. Now, the first step in building one of these AI agencies is to replace the software applications with these interface agents. This improves user productivity by allowing the human users to complete their work using natural language interfaces rather than requiring them to do all of the low-level detail work in code or in with like applications. And then we add some technicians off to the side that are going to support, manage, maintain, and train these interface agents. Next, we automate the human workflows using agentic workflows. Now, the workflow agents, they send their requests to the interface agents, the agents below them in that hierarchy, who complete the tasks in their respective subsystems that they're specialized to work with. And we add more human technicians off to the side in order to create, monitor, maintain these workflow agents. Then the next step is we try to automate managers using semi-autonomous agents. They're going to oversee the work being performed by the workflow agents and flexibly coordinate between one another in order to optimize efficiency through collaboration. And we add human managers off to the side so that they can oversee the automated work and assist with the edge cases, because those systems aren't going to be able to handle everything, and we don't want them to handle everything. Finally, our self-improving agents will eventually become smarter than even the smartest human executives. So we replace the human executives with super intelligent self-improving agents. And these self-improving agents will devise strategies to execute the vision, oversee those management agents, create new worker agents, optimize for each specific task or role that's needed. And then we move our human executives off to the side so that they oversee the agency and ensure that the goals and values of the organization are still aligned with our human goals and values. And that's it. That is currently the path we're on, leading to these fully autonomous AI organizations and eventually total labor automation, if some of the AI experts are correct. Each of these types of agents that we talked about plays essentially a building block in this organizational hierarchy of automation. We automate the value chain and we move people to the periphery of that value chain to oversee the work being done. Machines do what they do best, and humans do what we do best, the tasks we do best. And this is exactly the same thing we did in the Industrial Revolution when we moved people around the assembly line instead of inside of the assembly line. And the exact same thing we did with the Information Revolution when we moved people out of the flow of paper into computers on the periphery of the paper flow. So since these AI agencies, this is still like an emerging area of research. There are no fully autonomous companies that I am aware of yet. I'm guessing the first ones will be popping up this year, though. So we don't have any good real-world examples of what these look like yet. However, we do have some toy examples that show us the kind of shape of things to come. For example, we have Chat Dev, which is a team of agents that work together to design, code, test, and document new software from scratch. So we provide the manager with a description of the software that we want built, and then the manager delegates tasks to each of the team members. The designers go back and forth creating a user interface. The programmers write the code, send it to the testers. The testers verify the functionality, kick it back to the coders and it's not working. Then once that's all done, the writers document the software so that we understand what it's doing. And just a few minutes later, for a cost of about 10 cents, we have our finished application. Now, currently, ChatDev can only create the basic trivial games and toy software like Pong, but it gives you an idea of what an autonomous software agency might look like in the near future. And we also have another toy example that I think is really interesting called generative agents. Generative agents is a research project that simulates a small town of AI agents all kind of working together or side by side. The agents go about their daily routines. They perform simulated work, not real work, and they have conversations with one another. Interestingly, they exhibit surprisingly human-like social behaviors. They begin, like we've observed them now, planning Valentine's Day parties. They send out invites to their neighbors. The neighbors show up to the party and like actually socialize if they like the person. The ones that didn't like the person don't show up. They discuss local town politics. They talk about voting for a mayor based on their interactions with the individual candidates running for mayor. They share news, spread gossip, exchange ideas, and more. And once again, I mean, it's just a toy simulation, but it gives you an idea of what like a fully autonomous, potentially business, nonprofit, or even government might look like in the future. So the key takeaway here is that these AI agencies, this is likely the future of organizations moving forward. Many businesses, nonprofits, and governments are eventually going to be mostly, if not fully, automated. And those that are leveraging this kind of automation at scale will simply just outcompete the competition. Like if you can build software for 10 cents versus taking 2 years and hundreds of thousands of dollars, it's tough to compete with that. And those that don't embrace this, unfortunately, will just get outcompeted or become irrelevant or obsolete. And obviously, there are going to be exceptions to this. Just like every technology revolution, there are always exceptions. Things that we decide as humans, only we want to do, not the machines. But I mean, honestly, like how many of you are still riding a horse to work every day or writing handwritten letters to your clients and then mailing them through the mail? You can't compete if that's your business model anymore. Honestly, even if we wanted to stop this, I honestly don't think we could. There's simply too much money to be made and too many costs to be saved. The economics are just driving this forward. Like it would take some kind of giant outcry, and even with that, I honestly just don't think this can be stopped anymore. So what's most important is that we make sure that these AI agencies are benefiting as many people as possible, rather than just a few ultra-wealthy individuals. And we need to ensure that the goals and values of these AI agencies stay aligned with human goals and values in the next decade and beyond. Thank you.